This next topic that we're going to do is about the atomic emission spectrum. Now, this is a topic that we do in much larger scale, actually in the classroom during the year. But since your goal here is to pass our midterm, I'm just going to focus on what is actually on our midterm. So, in order to understand what an atomic emission spectrum is, you have to actually understand how atoms emit light, or how certain substances emit light. If you've ever been around, say, a campfire where people were throwing things in, or even seeing things like fireworks, you know that some substances burn different colors. Copper, for example, burns green, while strontium burns red. So the question is, what actually makes them burn those different colors? Now, the reasoning that I'm going to give you is not the full reasoning, and we don't know the full reasoning as of right now. I'm just going to give you the beginning idea. So what I'm drawing here, all this is a sample hydrogen atom. And that purple dot right in the middle, that is going to be our nucleus of our hydrogen atom. And the blue dot is an electron at what is called ground state. And what that means is that electrons like to be at the smallest amount of energy as possible. Okay, they like to exist in the least amount of energy. So that electron of a hydrogen atom is currently at ground state. Now what's going to happen is this electron is going to get hit with energy. Okay, now that energy could be a form of light, it could be a form of heat, but as long as it is hit with the correct amount of energy, what's going to happen is it's going to jump up a certain number of energy levels. When it jumps up that certain number of energy levels, the electron is then said to be at excited state. Okay, so the electron is first at ground state, it is hit with energy, and then it moves up to excited state. Now, electrons are not stable at excited state. Like I just said, they want to be at ground state. They want to be in the least amount of energy as possible. So what's going to happen after it's up at excited state for a little while, it's going to fall back down into ground state like that. And when it falls back down into ground state, that's when it releases light, right? In some sort of visible form that you can see. So again, let's review what happens. The electron starts at ground state, it hits with a certain amount of energy, it jumps up some levels, and when it falls back down, it releases some light. Now let's say it got hit with a different amount of energy. Maybe then, let's draw that over here. Let's say it only gets hit with a little bit less energy, and like so, and it only jumps up 2 energy levels. That means that when it falls back down to ground state, it's going to release a different color of light. Maybe this time it releases some yellow light. Okay, so the amount of energy that it gets hit with determines how high it will jump, and then again when it falls back down to ground state, it will release some color of visible light. Now that is not what's going to be on your midterm, but I think that will help you understand. Let's put it this way. If every different element has those energy levels, okay, so those black rings are the energy levels. If every different element has those energy levels that are spaced a little bit differently, that means that the electrons will have to absorb different amounts of energy, and they will release different amounts of energy when they fall back down to ground state. That's why copper shows green light. That's why strontium shows red light. So what that means is, if I show you this next thing, that means that every different element produces a certain emission spectrum. Okay, and what an emission spectrum is when you look at that that picture I have there, this is an emission spectrum for hydrogen. That means that hydrogen will only produce red light, a light blue, a blue, and two purples. Because however far apart hydrogen's energy levels are spaced, that's the only light that it can produce. The term that you need to be familiar with is this term quantized. Okay, energy is quantized. That again means that energy can only be absorbed in certain amounts, and it can only be released in certain amounts, and that's based on how far apart those energy levels are.